Kumran sir, we can't hear you.
Okay.
Yeah.
Okay. Good evening. Greetings for the day. Warm welcome to all. On behalf of Jaya Group of Institution, it's my pleasure to welcome you all for this webinar series. Today we have webinar on data in action. So today we have Mr. Venkatachalam R. Uh, uh, he's going to deliver on data in action. So when you say brief about Venkatachalam. Venkat is a proud alumnus of JEC Madras, and he went to do his PGTM from IIM Lucknow. Throughout his 15 plus years of working career, he has played roles ranging from insurance sales to banking analysis to more recently as a chief data scientist for a travel client. He will be sharing some inputs on this domain and what could be potential career options for students as well as working professionals to pursue. And before getting into the session, need to have a kind of instruction like at the end of the session, you can find a feedback form link on top of the chat box as a sticky note. I request every participant to click on the link and submit a feedback form. Upon the e-certificate will be generated and register your mail, and you will receive the e-certificate within a maximum of 4 to 5 days. I request everyone to type your name in the capital letter and type the valid email ID, because some of the time the participants may not receive the certificate because they have mentioned the wrong email ID. And the technology used here is purely rely on the strength of local bandwidth. If you have any audio and video issues, kindly click the reconnect button. It's placed on top of the screen. Don't leave the room. Do not close the window. Otherwise, the connection will expire. Due to some issue, you came out of the webinar room. Again, you have to register and click the webinar link to connect with us. If there is any technical glitch in our side, we will back in 20 to 30 seconds. So you do not leave the room or close the window. We will take the questions at the end. If you have any queries, please type your questions, and you can select the option key, select the Q and A mode, so that we will get the question easily. So with this short note, I once again welcome Mr. Venkatachalam, and it's about to Venkatachalam. Please.
Right. Am I audible? People who can hear me, just comment yes on the chat box. I will be able to see.
Professor, I'm sorry for the delay. Shall I
Okay.
or
Yes, ma'am. Please, ma'am. Just a minute.
hi.
We have Zeta Devi, ma'am, who is head of IT department. Please, ma'am, please take it.
I'm sorry for the delay. Sorry. Hi, everyone. This is Zeta connecting you in the webinar room. A very pleasant evening to one and all present in the webinar room. As there is a saying by Gandhiji, live as if you were to die tomorrow. Learn as if you were to live forever. I think this quote has come true in spite of the lockdown. Learning has not stopped. It's nice to see such a lot of participants from all around the state and the country to join this webinar for happy learning. Ladies and gentlemen, it gives me immense pleasure to once again welcome all the participants on behalf of the management, principal, and staff members of Jaya Group of Institutions to the SkillFest webinar series for the today's topic on data. And I like to extend my thanks for the support rendered last week. This support motivates us to organize more webinar series. We expect the same support. The technology used here is purely rely on the strength of your local bandwidth. If you have any audio and video issues, kindly click the reconnect button, which is found on top of your screen. Don't leave the room nor close the window because the connection will expire. Due to some reason, if you come out of the webinar room, kindly register again and click the webinar link to connect with us. And if there is any technical glitch in our side, we will get back
Venkat,
Yeah, I can hear you, sir. I think.
yeah. You can go ahead, Venkat. I
Okay.
think there's a problem, madam.
Okay. No problem. I'm audible for everyone, right? Because I've seen people typing yes. So I will assume I'm audible unless stated otherwise. What I will also do is, as a precaution, I'm just going to switch off the video so that we save a bit of bandwidth. Right. Let me also start the presentation. Kumaran sir is the.
Yeah. I will do it. Yes.
Perfect. Yeah, I can. I have the control. Yeah. Right. So thank you, Kumaran sir. I have known Kumaran sir personally for about 18, 19 years now. Passed out of Jaya Engineering College in 2003. And at that time, Kumaran sir was the HOD of the MCA department. The MCA guys had the privilege of being taught by Kumaran sir, which was one of the reasons why we were jealous about them. There was also another reason why we were jealous about the MCA students back then, because they got the newly constructed building of Jaya institutions, whereas the engineering students were in the older building. Anyway, that aside, thank you all for joining today's webinar. I was not entirely sure about the profile of my audience, so I would take the baseline of, say, a second or third year engineering graduate and accordingly tailor my next 55 minutes or so. Apologies if it sounds too basic to some of you, and sorry if it is a bit of overhead transmission to some. In the end, whether the session felt like an engineering drawing class or a digital signal processing class, either ways, do leave your feedback, as that would help me personally improve better later on in future. Right. Coming to today's topic, data in action. Now, the reason why I took this topic is really simple. Every action that we do today, right, whether it's consciously or unconsciously, generates tons of data. Data is like omnipresent. It's all pervading. From a simple game that you play on your mobile device to the searches you do online, to the selfies that you take on your mobile camera, we generate tons and tons of data that is captured, that is stored, and can be potentially analyzed, or it is already being analyzed for various purposes. Back in 2006, there was a British mathematician by name Clive Humby. He was working in a supermarket chain store called Tesco. He was running a loyalty program called the Tesco Club Card. Think of Tesco as our Reliance Fresh or the Big Bazaar equivalent in UK. So he said that data is the new oil. It is valuable, but if unrefined, it cannot be used directly. It has to be changed into gas, plastic, chemicals, etc., to create a valuable entity that drives profitable activity. So the data must be broken down, analyzed for it to have any value per se. The second reason, so the first reason was data is the new oil. The second reason why I think this topic is very important is uh, a Harvard Business Review article that was written back in 2012 said that data scientist is the sexiest job of the 21st century. This article was written by a person by name DJ Patel, who was the first ever chief data scientist at the White House. As I said, it got published in 2012, and sadly for me, I got married much before that, so it didn't really do much good to me as a prospective groom in the marriage market. But anyway, so this is the job of the century. The third and most important reason why I took this topic is this is an exciting field. The growth of data is unimaginable. And parallelly, there are technology stacks that support such growth of data, which helps in such data being stored, cleansed, analyzed, and interpreted, and to also churn out actionable insights in real time or near real time. There were studies in 2013 that suggested that 90% of the world's data at that time was generated in the last 2 years when compared to the previous years ever. So, which means that if I take all the data that has been generated in the world up to 2010 as X, just in 2011 and 2012, 9x times of the data was generated in those 2 years. And that data explosion has just been continuing even till 2020 and furthermore. This is a simple infographic by a data visualization and analytics product company by name Domo. This was done back in 2018. There is also a link down in the slide, so you can click on that and view the full report. So what it says is by 2020, which is this year, every person on Earth will generate 102 MB of data every minute. And that is the scale at which we are progressing today. Many studies suggest, or rather they put varying figures, but broadly we are looking at 45 to 50 zettabytes of data by the end of this year, which is roughly 40 to 45 times more than the number of stars that is there in the known universe today. So what is a zettabyte? One zettabyte is 1 followed by 21 zeros. That is 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. I actually timed it. It took me about 10 to 12 seconds to say this. So in that few seconds that I said all these zeros, the world actually would have generated enough data to fill 14,300 1 TB hard disks. 14,300 1 TB hard disks. That is the enormity of the field that we are talking about. Such data definitely requires newer technology, smarter ways, and newer methods to cleanse and interpret. And that is where this buzzword of big data came into existence. Big data traditionally was defined along 3 dimensions. You have the 3 V's, which is volume, velocity, and variety. This is one simple infographic from a PC Mac website, which I put out here. In 1992, so this is just to tell you, how big the volume of big data is, the first of the 3 V's. In 1992, much before most of you would have been born, right? 100 GB of data was generated in a single day. And it took about 16 to 17 months to generate 50,000 GB of data. 16 to 17 months is about 3 engineering semesters. Or if you're unlucky, writing 1 DSP paper thrice. So that is the amount of time that was required in 1992 to generate 50,000 GB of data, which today gets generated in less than a second. And all this growth has happened in the last 28 years alone. Today, 3 billion people have access to the internet, which was equal to the world's population in 1960. Right. We have discussed velocity, but this is the growth rate of data every second. Coming to variety, over 90% of the data that we generate today is unstructured, which means labeling the data as facts and dimensions is going to become all the more challenging. And cataloging and interpreting data is going to become a very difficult task. So in 1 minute, what does the internet generate? Just take Google search, for example. We are looking at 4 million search queries on Google every minute. To simply put, as a race, we have resorted to an easy way to seek out answers for our problems through Google in the last 2 decades. When I was growing up, when I was in school, when I was in college, libraries were the only place where we used to search. And the librarian was the treasure trove of information. And he will point me to the book that I need to go and pick up in order to answer the questions that I had. Today, that is gone, right? Most of us will be using Google. Even to find out directions, back in those days, we used to just go to the nearest chaiwala, the tea anna, and ask him how to go to a particular place. Now we just rely on Google Maps or Waze for everything. So this brings back to a very important point. The complexity in the variety of data that is getting generated is mind-boggling. Free text status field updates of Facebook, right? 140 characters of emotions on Twitter, pictures and short videos that you keep uploading on Instagram, or the video logs that we upload on YouTube, or the TikTok or Smule videos. Especially with lockdown coming in, we are using such applications like crazy. So it's just data, data, and data everywhere. So where is this going to lead us to? By 2025, we are looking at about 175 zettabytes of data. And of that, 50% of the data is expected to be on cloud and not traditional data centers. So, and of this 175 zettabytes, nearly 30% of the data will need near real-time processing. This is what a study by Seagate says. What more, 90% of this data will be unstructured, and 6 billion people will be interacting with data one way or the other. And there is going to be data generated every 18 seconds by a connected person by 2025, right? Very quick trivia. If you want to learn a bit more history about big data and how it arrived, you should look at a MapReduce white paper of by Google back in 2004. And that formed the basis on which Hadoop was inspired. So I have linked it here. You can read it at leisure. So coming to this main topic, now that we have the context set, why data is so important, who is a data scientist, right? We say data is the new oil and this has to be mined. So how can we build a career in it? Let me begin by defining what exactly a data scientist does. Many would have seen this, right? I saw a TEDx talk recently where someone hilariously commented, a data scientist is a slightly better programmer than a mathematician and a better mathematician than a traditional software engineer. And after working in real life with a few data scientists, I might tend to agree with that. They are neither here nor there. So they are slightly better in math than a traditional software engineer or a regular software engineer. And they are slightly better programmers than a mathematician. This is the Venn diagram that you would have seen or you might end up seeing whenever you Google for what is data science. There are three fields that converge to synthesize a new race called the data scientist. One is computer science and IT. Second is math and statistics. Third is domain and business knowledge. That's very, very critical. So computer science plus domain is where software development happens. Computer science plus math is where machine learning happens. Math plus domain is where traditional research happens. And the combination of all three is where data science happens. This is another view of a modern data scientist. If you look at it, he knows a bit of math. He has a bit of domain knowledge. He has a bit of programming and database skills. He also has a bit of communication and visualization skills. Net, if you ask me, he is something like this. This is my favorite dish called avial. So if I have to draw an analogy of a data scientist, he is nothing but an avial. So it's a dish which is a conglomeration of many vegetables with no single vegetable standing out. So data scientists and sometimes their work is also pretty much like this dish. So they do a bit of many things like programming, domain knowledge, math, reports, visualization, communication, etc. How does he look today in real life? So if you take real life examples, there was a study that was conducted, I think, in 2018, using a sample of profiles that was gleaned out of LinkedIn, who had titles called data scientist. It seems to be a male-dominated, but however, for no good reason. It's a fairly new profession as evidenced by the number of years of experience that the data scientist was possessing. Mostly, the programming language of choice was R or Python. 75% of them either had a PhD or a master's degree. Though personally, I don't think a master's degree is a must. As long as you have a flair for numbers and can think deeply logical and make sense of data, anyone can pick up data science. I will take you through how I have seen the evolution of data science personally in my work experience. So I switched to data science back in 2007. It wasn't really called as data science or decision sciences or machine learning engineer at that time. Those terms weren't that prevalent. So we were called as a simple database marketing team who were supposed to rummage through millions of banking transaction data to understand who has the potential to buy a credit card next or who might attract from the portfolio. At the end of the exercise, most of which was business rules driven, we used to produce a calling list that will be then shared with the sales agent or the relationship manager. The sales agent used to religiously call the list and check if the customer is interested in the product and accordingly make the sale. Normally, the journey of analytics, this journey of analytics is what any organization which is embarking, trying to use their treasure trove of data that is available in their source systems or the data warehouse will do. So they will start small, invest in a couple of analysts who will create such calling lists. And those calling lists are supposed to perform better than a random list. And that's how the journey begins. With this background, now let's get into various tenets of data science. I'm going to use the word analytics, data scientist, decision science, ML experts quite interchangeably. And depending on whom you talk to in the industry, you will get various definitions for their job function. But for the purposes of webinar, let's just assume they all mean the same. So let's put a framework of for data science. Quick time check. I think we are 25 minutes into the slot. Yeah. Okay. So Simply Learn, which is an online learning website, they have put out a nice framework on how typically a data science framework works. So it all starts with a business problem. So this is what I would call as the top-down approach. Rather than using the data that is there in hand and to start looking at the insights, if you start with an end goal or a business problem, it becomes a lot more easier. So start with business interaction, start with an end goal, start with a business problem. Once you know the business problem, you go on to do what is called as data acquisition. So data acquisition is, in order to solve the business problems, what are the various sources that I can go and glean data from, and what are the other relevant data sets that I can bring in to help solve the problem. So that is data acquisition. Then comes data preparation. This is a wide subject in itself. So building data ingestions, pipelines, and treating data to bring it into consistent formats and landing the data into a consumable format. All this encompasses that one phrase called data preparation. Then comes exploratory data analysis. This is where you torture the data for patterns, insights that you can use, select features that can potentially influence or solve the business problem in hand. Statistical data modeling. After building the features, next comes the actual algorithm. Most of the algorithms are available as pre-built libraries in programming languages today. The skill now that is required is to interpret the results that come out of these black box models. And understanding what goes within the model is a nightmare in itself. And hence, it is all the more important that a data scientist should have a good grasp on the various ways in which the results can be interpreted. Then comes visualization and communication. So presenting the model results and explaining the same to the business end user. And then finally, deployment and maintenance. Now, I would like to add, or rather highlight, a couple of more points which I think is relevant in this entire DS framework, the data science framework. Selling the model. This is a very important step because a data scientist should be able to know how to explain his model in non-technical terms to business users. There is absolutely no point trying to discuss a black box model, which is quite deep in statistics, to a business end user. He is not going to understand it. And that is not going to help you in terms of driving up adoption of a model in real life. However complex the model may be, the model and the results have to be presented, sold, and defended to the business user in a very, very simple and user-friendly term. If I were to build a supervised learning algorithm, such as say random forest, which I will talk about a little later, to predict if a consumer will buy a particular product or not, there is absolutely no point trying to talk about the various trees in the random forest or use any complex calculations. The data scientist should be able to explain in simple terms what features are driving the results. Why does the model potentially think that the customer will purchase the product? And often this is the most important step that is overlooked, which leads to a lot of failure in adoption of the model by the business. And I've seen many programs, being shelved because the business was simply not able to gain the confidence in the output of the model that the data scientist was building. So selling is a very important skill set that needs to be added into the DS framework. Another call out that I want to do is problem construction and solution design. How we approach the problem is the art in data science field. If you have a data set, there is absolutely no point blindly running algorithms on top of it. We need to construct the problem right and evangelize a neat way to build a solution on top of it. This is a separate session in itself, so let's not get too deep into it. And then one more call out is on decay, test control, and retraining. How do you determine if the model is working in real life? And when will you know that the model is not as good as it was meant to be? And what is the point at which you will retrain the model altogether? So let me simply put that as determining a benchmark for performance and understanding the model decay in production. As funny as it may sound, this is always a overlooked area. I have seen clients where a model was developed by some external consulting firm, which was completely black box, and the client was running the model for years together. There were no checks in place to see if the model was still performant or if there was a need to reevaluate the problem from scratch, etc. So in the years that the client was running those models, there were also newer data sources that came by, like customer browse data, that could immensely be valuable for the model as a feature. Unfortunately, there was no one to tinker the model, and the client was happily running an outdated model. So the moot point is, have a mechanism to track the performance of the model over a period of time. Right. Now, with all this, whether you're all confused or very clear, I'm hoping most of you would want to explore this field and build your careers in it. If that is the case, you can stay on. Or if you think data is not for me, you're free to log off. No problem at all. So I'll just pause here for a second. Right. So I'm assuming people are interested, whoever has stayed back, and I will continue. So from here, I'm going to fork my discussion into how you can build a career within the various sub-functions of data science. What are the steps you can take? And a few tips. And those tips are going to be more towards freshers or working professionals with less than 5 years of experience. Of course, if there are any mid-management professional or senior professional here, I don't have much to add, but I will try to give a few tips that I have seen working. So all the steps are here. The start with the business problem, data acquisition, data preparation, EDA, statistical modeling, visualization and communication, deploy and maintain. So all of these are sub-functions within data science. Over time, I believe the concept of specialist will start having different boundaries. The definition of specialist will start expanding, and different sub-functions can merge on to become a field in itself. So rather than going deep into one particular dimension, companies will actually look for individuals who can potentially play more than two roles. Like, for example, they might expect a data scientist to also be a pre-sales person, right? Or do some consulting, work for a month or so in order to win a client. Or they might expect a business analyst to also play a role of a data scientist. Or they might expect a pre-sales person to also play a role of a delivery manager. So the role of specialist in a particular sub-function will evolve over a period of time, and it's always safe to be well versed with more than one sub-function if you're going to get into the field of DS. Nonetheless, let me look at the world as it is today and the various options you have in terms of career. So first up is business interaction role, or start with a business problem. This is what we popularly term, the titles that you will get in various companies are business analyst or a functional architect. Typically, a fresher or someone with less experience might start off as a BA, business analyst, and over time progress to become a functional architect who can evangelize business roadmaps, technology roadmaps at a very high level, and can also support business roadmaps, go on to become a scrum master, project delivery manager, and so on. What are the key skills one need to possess? First and foremost, the most important skill is understanding the business. There is a world of difference between theoretical reading and practical application of business concepts. And I can tell you from my personal experience, I knew what a letter of credit transaction was theoretically, but when I first started working in a bank, to do my first letter of credit transaction, it actually took me 20 days to get the documentation right. Such a simple transaction to execute, it actually took me close to a month. So how do you acquire deep business function knowledge? You can acquire either by working in the business function teams as well as augmenting it through theoretical knowledge. Take banking, for example. If some of you are able to get into an IT function of a captive unit or of a bank, that is the best place to learn banking. To be a good, well-respected business analyst, you should aim to know at least two domains, and pick two domains which you think you're comfortable with, be it banking or retail and manufacturing. And in your first 5 to 6 years, focus on those two domains and try to get into projects that will be helpful to acquire those domain knowledge in your profile. The second most important skill set is converting the ability to convert business problems to technical requirements or data problems. For this, some amount of hands-on technical experience is a big plus. Some of the successful business analysts that I have seen were programmers themselves, and that helped them to quickly give business users the answers that they were seeking for, whether the problem at hand and the solution for that problem has a technical feasibility in terms of so the BA also starts looking very nice as a SME in front of the business user. He will not go and go with an answer saying, "Let me check with my technical architect and come back." He will be able to take a call then and there. So that is how you gain respect in the role. So being hands-on technical is a big plus for this role. Some of the tools that you can learn and equip yourself with to become a good business analyst: Excel, PowerPoint, very importantly, soft skills. If I had to pick one, I would say soft skill. And by soft skill, I wouldn't mean speaking grammatically perfect language, but good enough for others to understand clearly. What is your typical career progression as a BA? Well, you can progress from a BA to a functional architect and then to a business architect or consultant roles. Or from a BA, you can get into product owner roles. Else, you can take up delivery management roles after being a BA. So, like a Scrum Master, a project manager, a program manager, a delivery manager, and so on. Right. So that is on the business analyst or functional architect role. Coming to the next one, this is a very, very vast and wide subject called as data pipeline engineers, which is data acquisition and preparation. Data preparation encompasses source identification, coming up with something called as data cataloging. Data catalog is simply say what are the source systems and what business entities do they encompass. And then we do something called as a skeletal data dictionary. I'm not going to get into the various database modeling aspects like conceptual, logical, or physical data models. Nor will I talk about different data models like hierarchical, relational, etc., or star schema, snowflake schema. All this we can deal in another session, or you might already have it as a part of your engineering process. The data pipeline engineer should have the skill to do a skeletal data dictionary in such a way that it is not too detailed that it will take ages to create one, or at the same time, it is not too skeletal that the analyst will find the resultant data unusable. So this is where defining the problem statement comes in. We need to have an end goal as to what the business problem we are solving, and then take a top-down approach to understand what type of data is present in the various sources that can potentially help us solve that problem. Else, we will get into what is called as data merits, and unraveling from there and traversing the data glut will make us lose our precious time. Now, once source identification, data cataloging, and skeletal data dictionary is done, then comes the most important piece, which can also happen in parallel, that is the solutioning bit. So how are we going to build data pipelines to extract data from various sources, stitch them all together, and put it in a more consumable format for analysts to further work on? This extraction, load, and transform process of data and building a pipeline that can seamlessly do it, that is what is popularly called as ETL engineer. And you can look to skill yourself in one of the ETL tools that is listed here. So what you see on the slide is from Gartner's Magic Quadrant of last year, right? You can pick one tool and you can skill yourself in, say, either a Informatica or a Data Stage or a SAS or a SAP or a Oracle or a Talent and so on. There are also some new age pay-as-you-go cloud native tools that are available today. For example, AWS Glue, and it is worth exploring that too. One call out here, if you have to pick one fundamental skill set, irrespective of what tool you will end up working with in real life, that skill set, according to me, is writing good, decent SQL queries. And for that, a strong understanding of the underlying data, how duplicates are there, what kind of data quality are we working with, indexing, etc., is all very, very important. A tool expert, at least to me, means nothing without a strong SQL skill set. What are the various career options? From an ETL engineer, you can progress to become a lead architect, and then from there on to an ETL architect, and then to a solutions architect, after you pick up some infrastructure skills along the way, and then technical delivery management. So that's broadly the domain about data preparation, data acquisition and preparation. Coming to exploratory data analysis and visualization. All right, I'm going to club this along with BI reporting stack simply because most of the BI tools today have the capability to do EDAs, exploratory data analysis. Typically in IT industry, such roles are called as BI report engineers or as data analysts. Broadly, analytics can be classified into three vectors: descriptive, predictive, and prescriptive. Now, descriptive analytics is using data to explain what has happened. Predictive analytics is using data to forecast or predict what might happen in the near future. And prescriptive analytics is trying to tell how should you react if an event occurs. Now, furthermore, descriptive analytics broadly can be divided into two subcategories: tabulated data summaries and visualizing data. Tabulating data is like the 101 of data science journey. You start with structured data, which is what most of the traditional transaction-based processing systems hold. and you try to get the business dimensions and facts and try to do summaries which are of interest to the business user. So here I've just taken a few screenshots from Worldometer. The link is there below. A simple table summary of how coronavirus is spreading in the world. It's a nice, simple to use, simple to interpret tracker. The first screenshot will tell you how many new COVID-19 cases are there overall split by country. The second one is, how many deaths are there due to COVID, summarized at a country level. The third one is which countries registered the maximum new deaths yesterday. So as you can see, most of the questions that descriptive analytics answers are what has happened using the data, right? So these are about tabulated summaries. Coming to visualizing data, visualization is a often understated, and from my experience, it is one skill set that every aspiring data scientist should pick up. The simple reason is human beings can see before they can speak, and hence visualizing data is something that will appeal to everyone. Whether you know maths or not, visualizing data will really help in faster interpretation of the data, irrespective of whether you have a statistical background or not. That's in your genes. So let me give a quick kind of full disclosure. Sorry, Kumail, you have a question? Okay, let me continue. So full disclosure, I've straight away lifted the next section directly from a talk by one of the top data scientists in our country by name Yes Anand. He is the CEO of a company called Grainer, which is a Hyderabad-based data visualization company. So if time permits, please go through the website and also go through his YouTube videos. So let me straight away show what he did in that YouTube video. Can you guys quickly count the numbers that are below 10 in this? Just post it in the chat window. Just take a guess within 10 seconds. Count the numbers that are below 10. So I get an answer as 3. Anybody else who wants to take a guess? 18. So I have a 3, I have a 18, I have a 20, I have a 7, I have 11, I have an 18, I have an 8. I have another 8, I have a 9, I have a 9, I have a 30 plus, I have a 15, I have a 7, I have an 8, I have a 9. Right. So let's take a pause. So we took about 30 to 45 seconds for this exercise. Now, if I do a simple, a very simple conditional formatting on this and just color the numbers which are less than 10, and then if I ask you to guess it. Now, can you count or guess the numbers that are colored in green? Right. Now I'm able to see more guesses which are around 10, 11, 11, 11. Yeah. Right. So this was just a very small demo on how a very simple hack like conditional formatting can, help you interpret data. So it helps you to know the results faster. It is also more accurate, and it answers your questions a lot more quicker, right? There are many visualization tools out there in the market, and you can refer again to the Doctor's Magic Quadrant to see which are the tools that are there in the leaders, challengers, players, and visionaries category. The market leaders are Microsoft Power BI, Tableau, Click, and TopSpot. So you can pick one and learn. I will also show a quick screenshot on the art of the possible using visualization. So this is a screenshot. This is actually a screenshot from Domo, who's a BI, who's one of the niche players in the BI market. The link is down below. You can click there. There is a live tracker there. Just look at the amount of information that is present in this single dashboard, right? That is the power of visualization. And that is how we have to use visualization for storytelling. There are geographical heat maps that quickly tell us which countries are the most affected. There are micro charts that tell us what the trend is and so on. A lot of information can be packed in a single dashboard. or a report through right visualization techniques. It should not be overwhelming. It should be easy to interpret, pleasing to eyes, and with one look, we should be able to understand what is that the BA report engineer is trying to convey. Right now, how can you build your career in this sub-function, which is EDA's visualization, BA report engineer, or data analyst? One basic life-saving skill set that you need to have, not just for this sub-function, but overall in IT industry, is Excel. Excel is an underrated tool, but trust me, I have done most of my prototyping on data analysis, report markups, summaries, interpretation, everything on Excel largely. PowerPoint is another underrated tool. The latest versions have quite a lot of interactive capabilities, PowerPoint, and storyboarding is also quite simpler in PowerPoint. By all means, also pick up a BA tool and learn. If you're confused which tool to pick up looking at the magic quadrant, the safest option is Microsoft Power BI or Tableau. And if you learn one tool well, learning another tool is very, very easy because the foundations are very similar. Coming to your career progression, from a BA report engineer, you can progress to become a data analyst or as a BA architect. You can also make a choice to become a data scientist as well if you are well versed with handling and interpreting data because of your reporting experience. One pro tip here, if you want to learn Excel well, check out this website called chandu.org. It's phenomenal website. I refer to it all the time, and you'll be amazed by what Excel sheets can do. And to be brutally honest, I have been able to survive in the IT industry largely due to my Excel skills. Fine. So we have covered business analysts, we have covered ETL engineers, we have covered BA report engineers. Now let's come to the crux, which is the data scientist, right? Broadly, most of the problems you will solve in real life using statistics will come under two types of machine learning algorithms. Broadly, supervised and unsupervised. Supervised learning algorithms are problems where you give an answer and ask the algorithm to learn from the answer. It's like an open book exam. So you're given a data set of, say, housing data. And in a very simplistic scenario, you might have one feature, like the area of the house. And let's say we also have against the area of the house, we also have the price of the house. So we have the area, we have the price of the house. Now we can employ an algorithm that will learn from the price of the house if area was an influencing factor or not. We call this as a simple linear regression equation, y is equal to mx plus c, which all of you might have studied in your school days. This y is the price of the house, x is the area in square feet. Now, using this equation, you can start predicting the housing prices if you get a new data set, right? Unsupervised learning algorithms are used in problems where you don't have the luxury of knowing the answer to learn. So these are typically your clustering and segmentation problems. Now, keep all this aside. There are tons of algorithms that are out there which can be used to solve a given data problem. Somebody actually did a map of what all algorithms that are there and how one should start their journey while trying to learn various statistical algorithms. And that's how it looks. Quite complex, right? So this map of various things that you might end up learning and using, or sometimes using without learning in real life, where do I start this journey from? What are the skills I need to acquire to become a statistical model or a data scientist? Well, key skills, you need to have a good grasp of a programming language. There are purpose-built programming language for statistics like MATLAB, Octave, R, Pika, or you can pick up a general purpose programming language like Python, which has tons of optimized libraries that you can use to build models. Personally, I will highly recommend Excel and Python as two tools to go deep and invest your time, whether you are a fresher or working professional. Python is also a general purpose programming language, right? So it will also greatly help to automate some of your real life mundane activities. Next, the fundamentals of statistics and having a deep understanding of 3 to 4 models is an absolute must. Most of the models today are black box models, and it is difficult to make sense of the inner working of the model and to defend your result. That is why interpreting the results of the model, such as accuracy matrices like confusion matrix, for example, comes into picture. Then comes the art part of data science, which is problem construction and solutioning. There is no point blindly running an algorithm on a data set. Constructing the data set in such a way that it is contextual is something I find lacking in most people today. So how do you develop this skill set? We will see it in the next slide. Coming to your career options, on a lighter note, a data scientist is born as a DS, lives as a DS, and might probably end up dying as a DS. writing several lines of code till the end of his career. But in recent times, there are newer senior roles that are emerging, like principal data scientist, where you tend to lead a team of DSO, or ML architect, where you evangelize a data problem and its solution end to end. And then you can progress to become a chief data scientist or a chief data officer or a chief analytics officer. So there are options. Of course, this is also a very lucrative career path at this point of time. So definitely you can explore this subfunction. Right. Where do you start? For a fresher or for someone who's a working professional with say 5 years or 10 years of experience, there are a few links that are there on the site. To learn Python, there are some good Udemy courses available. Once you know the basics, so, I personally use something called as projectoiler.net. This has, I think, thousands and thousands of mathematical sums. And there are a good set of problems that you can solve programmatically. You can use brute force initially to solve some of the problems that are in Project Euler, but it will force you to think smarter because your machine time will become a constraint over a period of time. Say, for example, you have to sum all the prime numbers that are below 1 billion. You can use multiple for loops and do it. It's just that it might take, say, 34 minutes to run. So you will be forced to think a little smarter, write your algorithms a little better, so that the complexity of the execution will come down. So Project Euler will discipline you as a programmer. So learn Python, practice Python. Then coming to data science, I would strongly recommend a course on Coursera by Andrew Ng. You might be able to audit the course for free, I think. I have done this about 3 years back, so I don't know if it is still free. And once you get a good grasp of a few supervised and unsupervised learning algorithms, download the data sets that are available on websites like Kaggle and try to solve it. Once you have solved it, also check out what the other data scientists have done and look at their notebooks also that they have uploaded on Kaggle. Lastly, I strongly believe in this learning pyramid. By teaching what you learned, you will tend to retain and sometimes even understand better the concepts you learned. I do this at every given opportunity. Whenever I get a captive audience, I will bore them to death using all the concepts that I have just right. We are almost nearing the end of the presentation, so this is my final slide. Coming to the deploy and maintain subfunction of data science. So this is where the boundaries between infrastructure, DevOps, and data science kind of blurs. Productionizing models is a really niche skill set, and monitoring the model performance in terms of baselining, setting up test control groups or fallow groups, model efficiency matrices, etc., comes into experience. Now, DevOps is a much more broader function than that, and it is a well sought after, well paid job currently. And it is the entire system's ownership rests with this function. And with the advent of cloud, it is also a domain that you should look out for in future. So check out some AWS and Azure certification courses if you want to make a start. And for model productionization techniques, check out papers on container-based productionization and API-based real-time pipeline integration stacks. Right. So with this, we have come to the end of the session. For a change, I have been able to stop at least 8 minutes ahead of my time slot. So which means we are open to questions now. Kumaran sir, do you want
yes,
to?
yes, yeah. Madam,
yeah, I'm there.
Yeah.
Any questions to be asked? Like you can post it in the chat.
So there was a question. What do you mean by data tunneling?
I mean, there are newer and newer terms that keep coming, right? So everything that is coming under pipeline ingestion. So data tunneling is also a part of that. So how do you extract data from sources, especially new age sources? How do you glean data from each of these sources and bring it into a data lake, right? So all this come under a subdomain within data pipeline ingestion.
Okay. So there is another question. Unorganized sectors like poultry industry, how to collect the database? It is very wide market production, labors involved in this business. but it is a 20 to 25 billion dollar business.
I haven't really worked in unorganized sectors prior to this. So unless the companies that are working in the poultry industry make their or anonymize their data and make it open source, right? It's very difficult to collect the data from such companies because most of this data will be either in you know not so connected computer systems, so in local Excel sheets, etc., or it might be in printed papers, or it might be noted down in bills, right? So it's very, very difficult to bring it all into one system, and unless they take the effort of putting it into systems and anonymizing the data and open sourcing it, it's almost impossible to bring it into a single database.
And that is all the questions being posted, sir.
Yeah, so there is one more question which I'm able to see. So fresher from math stream pursue data scientist career? Yes, absolutely. As I said, look through the courses that I have posted. Try to get the real world problems that are posted on Kaggle and try to solve that. That is how you gain experience. So get your hands dirty. It's only through practice that you will be able to pursue the stream.
Thank you, sir. Thank you very much, and it was a really an informative session. Thank you for sharing your knowledge and time with us too. As I had some problem with my internet, I couldn't just introduce our speaker. I'm sorry for that. And I now take up the opportunity to just introduce you. Sorry, Venkatachalam sir, I'm sorry. Here we have an eminent personality, and it is also a bit very nice to introduce after the session too, I hope. Here we have Mr. Venkatachalam Ramakrishnan. He's the Director of Advanced Technology Group, Harman International, Lucknow, London. He has pursued his engineer's degree in information technology. I'm proud to tell he's our alumnus. He's from Jaya Engineering College. His Master of Business Administration from Indian Institute of Management, Lucknow. He started his career as an area sales manager in ICICI Prudential Life Insurance Company Limited and played various roles as managers in Citibank, India. Associate Director in Happiest Minds Technologies. He has 15 years of experience across BFSI, betting and gaming, travel and retail domain. He has played vital roles in data science, engineering, product delivery, service delivery management, sales, and sales management. He has sound knowledge in business analysis management, SQL, SDLC, CRM, banking, etc. It goes on and on. With this short introduction, I'd like to thank Mr. Venkatachalam for his valuable presentation, and it was really an amazing session. We'd like to tie you back again for another webinar or seminar, which is possible. Thank you so much, sir. And we had a very good feedback too, and it was a very valuable session, and it was very useful too. So thank you so much for connecting with us, sir. I take up the opportunity to thank our chairman, Professor Dr. A. Kanagaraj, Secretary Madam, Mrs. Vijay Kumari, Vice Chairman, Mr. K. Navraj, and our Joint Secretary, Mrs. K. Deena, for their support. I once again thank our speaker for his valuable presence with us. I thank the participant for their kind cooperation and support. So thank you once again. And I like to just give some information about the feedback form. And the feedback form, here at the end of the session, you will find the feedback form link on top of the chat box as a sticky note. I think you can see that. I request every participant to click on the link and submit the feedback form. Upon that, the e-certificate will be generated and reaches to your email. You will receive the e-certificate within a maximum 4 to 5 days. If you are not able to receive the certificate, you can write to us. We will resolve the issues as early as possible. In the feedback form, I request everyone to type the name in the capital letter. Whatever you type in it, the same will be printed in the certificate. Also, provide correct email ID, otherwise you will not receive the certificate. With this instruction, let us take up the opportunity to thank everyone for being connected with us. And not only that, let's be connected for the next event tomorrow at 11 a.m. on the topic Disrupt, Innovate, and Transform in the era of COVID-19 by an eminent nuclear scientist, Dr. J. Daniel Chalapa. Until this, it's bye from Ms. Sita. Thank you. Stay safe. Happy learning. Thank you once again. Thank you, one and all.
Thank you all. Thanks a lot for hosting me. Bye.
Bye. Thank you. Thank you so much. Kumran sir?